Hi everyone, welcome to this presentation on synthetic data generation as a privacy enhancing technology. In this presentation, we will explore how synthetic data is created, the techniques used to generate it, its benefits and limitations, and a real-world use case, particularly in the healthcare sector. The goal is to understand how this technology supports both privacy protection and data utility in a world where data sensitivity and regulation are becoming increasingly critical. Now, what is synthetic data? Synthetic data is artificially generated information that mimics the statistical properties of real data without replicating actual identities. The generation process begins with the collection of ground truths data, which includes real world facts, theories, and datasets. Based on this foundation, a generative model is built using one of three approaches: knowledge driven, data driven, or a hybrid of both. Finally, the model is used to generate synthetic samples that replicate real data patterns while preserving privacy. The process of synthetic data generation begins with ground truth collection. This step involves gathering relevant facts, theories, and real world data that form the foundation for generating realistic synthetic datasets. Next, a generative model is constructed. This model can be knowledge driven, rely on predefined rules and experts' insight, data driven, based on machine learning algorithms trained on actual data sets, or a hybrid approach that combines both strategies to enhance accuracy and adaptability. The final step is data generation. Once the model is in place, synthetic data is created by sampling from it. This step ensures that the new data mirrors the statistical characteristic of original data sets while maintaining privacy through mechanisms that prevents the re-identification of individuals. There are three main techniques used to build generative models for synthetic data. The first is a knowledge-driven approach, which relies on expert-defined rules and domain knowledge. An example of this is Cynthia, a tool used to generate synthetic health records based on clinical guidelines and established protocols. The second is the data-driven approach, which employs machine learning techniques. One of the most notable examples is generative adversarial networks, where a generator creates synthetic samples and a discriminator evaluates them against real data. Through continuous competition and iteration, the generator improves producing outputs that closely resemble real data. This technique can retain up to 99% of the original data's utility. The third approach is hybrid, which combines both expert knowledge and machine learning. This method leverages the strengths of both strategies, leading to more accurate, realistic, and adaptable synthetic datasets. Synthetic data offers several compelling benefits. It enhances privacy by excluding real individuals, reducing the risk of breaches. It also supports compliances with regulations like GDPR, CCPA, and HIPAA, while increasing efficiency by allowing faster data access for machine learning, testing, and research. Additionally, it promotes fairness by addressing bias and improving inclusivity in datasets. However, synthetic data generation can be complex and resource intensive, requiring specialized expertise and computing power. There are also challenges in ensuring data quality, meeting legal standards, and evaluating how realistic or effective the synthetic data truly is. Now that we have explored how synthetic data works, let's consider its application in healthcare, a highly regulated and sensitive domain. Access to real patient data is restricted due to privacy laws like GDPR and HIPAA, making it difficult to develop machine learning models. Synthetic data provides a solution by enabling the creation of realistic, anonymized patient records for research and model training. A key example is the use of synthetic health data in cancer prediction models. These artificial data sets mirror real data patterns without linking the actual individual. This allows researchers to innovate and collaborate while staying compliant and safeguarding patient privacy. In conclusion, synthetic data offers a powerful privacy preserving path forward for advancing healthcare and other data driven fields.